kinematic equations. Well, in physics, we have these set of equations that we use to quickly figure out different variables such as initial speed, final speed, time, acceleration, displacement or distance. And so students become pretty quick at figuring out which equations they need to use, and these 4 or 5 equations are slapped in front of you, and you just are supposed to use them. Well, we'll learn how to use them, but today I just want to show you where they just kind of pop up from. And you really already know the basis of them already. Let's take a look at something simple like a velocity time graph of a car that starts from some velocity, v initial, and speeds up to a higher speed. Call that Vf. And again, Vi might be 10 meters per second, and Vf might be 40 meters per second. It doesn't really matter. And let's say that this is all done over a time period, t. Now, there's 2 important things you've learned already about velocity time graphs. One, how do you find the acceleration from a velocity time graph? I hope you said find the slope. That's all you have to do. And how do you find the displacement from a velocity time graph? I hope you said you find the area under the curve. So again, displacement is area under curve, and acceleration is the slope. Okay? And that's all that's where all the kinematic equations come from. Right from just there. Let me show you how. First, let's look and see how would you find the displacement of this graph. You'd say, I'll find the area. Well, there's 2 ways you could find the area, right? You could break it into a triangle and a rectangle and add them up. Or you could think of this as a trapezoid where these are the 2 parallel sides and these are the 2 other sides. So these are the parallel sides, and remember, for a parallelogram, for a trapezoid, we said that the area was a plus b over 2 times h, where if I have a trapezoid that looks like this, and this is a, this is b, and h is the height. Right? You guys remember that? So that's exactly what we're going to use here. We're going to say that the displacement, because that's supposed to be the area is displacement, so the displacement will be A. A is your 2 different heights here, which you can kind of see this is kind of turned sideways. So we're kind of looking at the trapezoid like that kind of thing, okay? So A is the same as the initial velocity. That's this height right there. And then B is this height right there. That's got to be Vf. Divided by 2, and h here is your time. And voila, right there is your first kinematic equation, number 1. Okay? How do we get that? Simply from here. The second one, again, we'll use the same graph. How do we find the slope for this line? That's the acceleration, right? So the acceleration is equal to the rise over the run. The rise is Vf, and this is Vi. So Vf minus Vi, that's your rise, over the time, which is your run. And so right there is your slope. That's how you'd find the slope of this to find the acceleration during this time. How fast is it accelerating when it's going from Vi to Vf? So right here, I'm going to take this equation and multiply both sides by t. So I have Vf minus Vi is equal to A times t. And then I'm going to add Vi to both sides. And voila, I get the second kinematic equation right there, 2. Okay? continue on with part 2.